All right, guys, we're going to do another one of these little flipped lesson or flip day sort of things so we can self-grade our Chapter 5 Mastery. So you need a pen or a highlighter, something that you can actually do some grading with. And then it is your responsibility to call me over if any of this stuff doesn't make sense. We're trying to be more efficient so I can help people with their individual issues. But if everything that we go over makes sense and you got the questions right, just check them off and keep moving on. So, all right, in number 1 here, we're converting to fraction and decimal. So if you forgot to do both of these, you need to go back and make sure that you did fraction and decimal. And remember, revisions, big changes need to be done on a separate piece of graph paper. So I was silly here. I actually went into fraction form and then back to percent form and then into decimal form. But percent means out of 100, even when it's 145%, means out of 100, which means it's going to be a decimal number larger than 1. Any percent larger than 100% is going to be larger than 1 when we convert it to a decimal. 28%, 28 over 100, 28 hundredths. 2%, same story, except now it's 2 hundredths. Double check that you didn't accidentally put 0.2. 0.2 would have been 20% instead of 2%. I printed this before I changed what was written here. I changed our student name. I changed the amount of shots taken to be 420 because that number works out nicer when I try to do 10% and then 5% especially. So if I break this down into, if 100% is 420, 10% would be 42, 5% would be 21, 15%, if I put my 10% and 5% together, would be 63, and that's the amount of misses they had. So I could calculate this by just subtracting away the misses. I could also do 10%, so that 42 shots, times 8, and then add 5 more percent on. Either way, we should be getting to 357 bullseyes. If you did not get that, please call me over and ask me a question about that. This problem seemed to give a lot of us an issue as we were calculating through it. 2 different ways to do it. That's why I have this big capital OR. So percent can be found by doing part divided by whole. Guys, this was in our Chapter 5 math notes. This is not a concept that should be that foreign to us. But if we haven't had much practice doing it this way, we might default to the other route of, okay, if the total bill is $40, that's your 100%. So 10% would be $4, 1% would be 40 cents. So if I calculated going this way, I would have gotten 0.14, which becomes 14%. If I calculate this way, I need a 10% and then 4 more 1% to add up to 560, like $5.60. So that is how we could make 14% here. That's a 10%, and that is 4 1%, making 14%. So not a fantastic tip, right? Maybe their service wasn't great. Who knows? Our total here is awkward. Our total here is 102. So if we calculate them out into decimals, the decimals are not nice. So you can see here again is kind of supporting my argument that fractions are better. I'm not saying I told you so, but in this situation, I think fractions are better. So we get 22 over 102, 36 over 102, and 58 over 102, respectively. The white or green, for the white or green, or means we need to add them up, right? Either one would make us happy. So white or green, we add those up to get 58. That's how we get 58 over 102. Moving to the back to number 5, I put my tree diagram on a piece of graph paper. Remember, our tree diagram is for our burrito shop. So we're picking salsa, either hot or mild. Protein, either beans, chicken, pork, or beef. Yes, beans are a protein. And finally, rice or no rice. So I have my salsa choice, I have my protein choice, and I have my rice or no rice choice. Guys, we only make one choice at a time. But to make the entire burrito, I need to have made all 3 choices. So my total burritos are just the end of my tree diagram. So 16 total options. So the probability of getting hot with chicken and rice is 1 out of 16. This is only one burrito. Even though it was 3 choices, it is one burrito. It's 1 out of 16. You need an accurate tree diagram on your test, and you need the accurate probability. All right, moving on to number 6. So I solved it both ways. Your probability of stop, if you say go on yellow, if you go on yellow, your probability of having to stop is 1 out of 3, or 30 over 90 if you did not simplify. If you stop on a yellow, that now means there's 35 seconds of stop. I think I did this wrong. I think that was supposed to be 35 over 90. Give me just a second here. Let's fix it. Great example / reminder that we all make mistakes. If we stop on yellow, that gives us 35 seconds to stop. So our probability down here should be 35, not 25, 35 over 90, which then gives us 7/18. So if you reduce it 7/18, if you leave it as 35/90, that is totally fine as well. So now our outfit problem involving Vic and our 3 pairs of pants, 2 dress shirts, and a yellow or green tie. So for part A, for my tree diagram, here's that whole tree diagram, right? Choice of pants, choice of shirt, choice of tie. So we end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total options. So then B says he could wear either, let's get this out of the way, he could wear either tie, right? He wants black pants and a striped shirt, so I'm going to follow up black pants and a striped shirt, but either tie, I have 2 options out there out of my 12 options. So black and striped with either tie, 2 out of 12 or 1/6. However, in part C, what's probability he will get blue pants, white shirt, and green tie? Blue pants, white shirt, green tie is only one of my total 12 options at the end. So 1/12 there. All right, for number 8, we have 4 different types of vehicles. So my spinner for type of vehicle, car, truck, van, and motorcycle. My spinner for 3 different colors, green, blue, and white. So then a table that would have represented this, I have told you guys that I normally go my more options across the top. So I kept my color coding with my spinners up here, green, blue, and white. White would be hard to draw in white, so I just drew that in black. So my colors, green car, green truck, green van, green motorcycle, right? Likewise, blue car, blue truck, blue van, blue motorcycle. So make sure that your table makes sense when you look at it, that you know what color, what car, or vehicle type. I guess I shouldn't say car. So the probability of spinning a white van. So white is this bottom row, van is right here. So white van is just one option out of our total 12 options. Blue car or green motorcycle. So blue car is 1/12, green motorcycle is 1/12. Together, 2/12 or 1/6. And the probability of a purple truck, regretfully, there is no purple, so our probability there would be 0. For number 9, I set up my 5D process, but instead of guessing and checking, I actually didn't do this part first. I did this part over here first, because after I set up my 3 different sides of the triangle, I was able to put them all together and essentially then go ahead and use algebra to solve. So I know this says use the 5D process, but if you're comfortable with algebra, you're able to use it in a lot of situations. So if I take 8 away from the entire thing, I end up knowing that my 4x's need to be 40, x comes out to be 10, and then I can plug it back in and check it. Maybe I had guessed an 8, like if you did the 5D process, maybe you guessed an 8, maybe you guessed a 12, found out you're too low, too high. But if I tried 10, then my unknown side plus 5 would be 15, and then my 2 times that unknown side plus 3 more would be 23. If I add these all up, I should get 48, and we do. All right, now on to the back. The biggest issue that people had here was being able to write that Donovan caught 1 less than 3 times as many fish as Ivan caught, which is like a long sentence to be able to dissect and figure out how to write that. But if we give Ivan the variable I, and we say Donovan caught 1 less than, well, here's your 1 less than, right? Minus 1 from something. I'm going to go ahead and just highlight that a little bit more. So minus 1 from what? Well, 3 times as many as Ivan, so 3i. You can write 3 times I, or you don't have to. But altogether, what would they have caught? 4i, right, and I there, and 3 more I there, minus 1 will equal their total of 31 that they told us up here. We can add 1 to both sides to deal with that minus 1. We can figure out from there that 4i has to equal 32, which means if we do division on both sides, I would equal 8 fish. If we plug that back in, 3 times 8, but then take 1 away, we get that Donovan would have caught 23 fish. If we add these up, should be 31, and it is. Same sort of process with 11, which is kind of why I do my tests like this. If you struggled on 10, you could have skipped it and moved on to 11. So on 11, we only have 2 pieces of rope, a shorter piece and a longer piece. The longer piece is 18 more than the other one, 18 more than the shorter. Now you also could have said that the shorter is 18 less than the longer, but you don't want to say both. You only want to use one of those statements of one is 18 more or 1 is 18 less. Don't use both, right? So if I make my small side equal to s, my larger side equal to s plus 18, I can put them together. I can use the algebra of do the same thing on both sides to get rid of that plus 18. I can get rid of that 2 by dividing. Figure out that the small would be 33 meters. So the longer one would be 51. If we add those up, does it get 84? You betcha. And our final problem here that we can definitely use algebra to solve. We have 3 sides of our triangle. I color-coded them x plus 2 for my first side there, 2x plus 3 for my second side, and then 3x minus 2. But then in my light blue, I'm going to gather all my x's. Remember, 1x, 2x, and 3 more x's make 6x total. I have a positive 2 and a negative 2. Be careful there, negative 2. So really all I have for constants is an extra plus 3. I can subtract 3 from both sides, getting that 6x would have to be 36. Then I can divide, getting that x would equal 6. And from there, I can plug in, if x is 6, 6 plus 2 is 8. 2 times 6 is 12, plus 3 more is 15. And 3 times 6 is 18 minus 2 gives us 16. So once we know x is 6, that's not our answer. We got to determine each of the side lengths. So we plug it back in and determine the side lengths that way. If you guys have any questions from anything we just went over, I know that was really quick, so please raise a hand, ask me about that. Otherwise, if you need to make corrections, and then turn that back in, right? I need that turned back in or else it's going to count as missing. All right, thanks guys. Have a great day.